A new declaration from NASA's leading astrophysicists has sent shockwaves through the scientific community. Betelgeuse, the epic red supergiant star, is showing signs of extraordinary instability that could lead to its catastrophic collapse at any moment. For years, astronomers have speculated about when this colossal star might go supernova. However, recent data captured by the James Webb Space Telescope suggests the event could be imminent. Here's why this matters. Betelgeuse is so massive and close to Earth that its explosion will be visible even during daylight. Its effects could ripple through our solar system in ways we are only beginning to understand. Disturbingly, the latest images from the JWST reveal strange infrared signatures, heat surges, and mass ejections that indicate an acceleration in the star's life cycle. Imagine a night sky permanently altered, constellations broken, and the possibility of cosmic debris spreading closer to our region of space. Are we prepared for the fallout? NASA's intensified focus on Betelgeuse raises questions. If the star goes supernova in our lifetime, it could redefine humanity's understanding of the universe and our place within it. Betelgeuse, one of the brightest and largest stars in the night sky, is nearing the end of its life. Its potential explosion as a supernova is expected to rewrite the rules of astrophysics. What makes this even more extraordinary is the possibility of an asymmetric explosion, where a massive burst of energy and matter could be ejected unevenly, creating shockwaves capable of reaching neighboring star systems. Recent data from the James Webb Space Telescope and NASA's Chandra X-ray Observatory suggest that Betelgeuse has undergone an unusually large surface mass ejection (SME), a phenomenon never observed at this scale in a red supergiant. This SME released more than 1 billion times the energy of a solar flare, and its trajectory suggests a troubling potential. An extreme burst of plasma and radiation could target surrounding star systems. Such a scenario raises urgent questions. Could this wave disrupt the delicate balance of gravitational forces within our galaxy? Could nearby systems, including those with habitable zones, experience devastating consequences like altered orbits or increased radiation exposure? These are not idle theories, but pressing concerns driving NASA's renewed focus on Betelgeuse's behavior. Simulations show that if Betelgeuse explodes asymmetrically, the debris field could expand unevenly, creating dense pockets of interstellar material. These regions could collide with other celestial bodies or even interfere with critical space exploration missions in the coming decades. Perhaps most concerning is that no one knows precisely when this event will occur. The buildup of unusual energy surges points to a ticking time bomb, but how close are we to detonation? And if it happens sooner than expected, what secrets could the explosion reveal that we aren't prepared for? NASA's James Webb Space Telescope is not just observing Betelgeuse, it is rewriting the playbook on how we study dying stars. What sets NASA apart is its cutting-edge infrared capabilities and access to global collaborative expertise. This positions Webb as the leading tool capable of detecting subtle changes that could signal the star's imminent collapse. Webb's ability to capture infrared radiation from deep space allows it to peer through the gas and dust clouds surrounding Betelgeuse. Recent readings have revealed sharp spikes in energy levels and erratic material ejections from the star's core. This level of precision is something traditional telescopes, including Hubble, simply cannot achieve. NASA is using Webb's data to build predictive models correlating surface mass ejections with the final stages of a supernova's life cycle. If successful, this would mark the first time in history that astronomers could predict a star's collapse with accuracy. Betelgeuse's explosion, though millions of light-years away, carries potential risks to satellite technology and space exploration. NASA is actively coordinating with the European Space Agency, ESA, and other organizations to develop contingency plans for surviving increased radiation and potential interference with Earth's orbiting satellites. This joint effort is critical because, without these measures, a sudden supernova could jeopardize everything from Webb's advanced spectrography capabilities to global communication networks. Webb's advanced abilities allow it to measure the chemical compositions in Betelgeuse's emissions, providing a real-time view of the star's instability and identifying warning signs missed by traditional optical telescopes. This technology, combined with NASA's Deep Space Network, gives scientists a 360-degree perspective on the evolving phenomenon. If NASA's models fail, humanity risks missing the first real opportunity to observe and study a supernova in its early stages, a loss that could set back our understanding of stellar evolution by decades. Even with Webb's advancements, astronomers acknowledge the unpredictable nature of stars like Betelgeuse, leaving room for error. The timeline for such an event remains speculative. Later simulations, grounded in cutting-edge findings from the James Webb Space Telescope, reveal that the star's potential explosion as a supernova could have cascading effects, reaching far beyond the star itself. The broader implications of Betelgeuse's impending explosion raise questions about whether the event could serve as a catalyst for advancing humanity's understanding of the universe, or if it will expose vulnerabilities in our preparedness for cosmic phenomena. Astrophysicists are particularly concerned about the challenges of monitoring and responding to such an event. While the James Webb Space Telescope, JWST, and other observatories provide unprecedented insights, the sheer scale and unpredictability of a supernova explosion raise concerns about our ability to adapt and respond effectively. Collaborative efforts among global space agencies, universities, and private organizations are critical to ensuring that humanity can leverage this rare opportunity to advance science and technology. If Betelgeuse's explosion unfolds as predicted, it could offer groundbreaking insights into element formation, black hole formation, and cosmic radiation impact. Observing the formation of heavy elements like gold and uranium in real time could revolutionize our understanding of stellar nucleosynthesis. If the star collapses into a black hole, it would provide a rare chance to study the process directly, potentially challenging existing theories. The event could also shed light on how high-energy radiation interacts with nearby star systems and interstellar space, offering critical data for future space exploration. However, the challenges are equally daunting. The radiation from a supernova could trigger magnetic storms on Earth, disrupting power grids, satellites, and communication networks. Satellites and space missions could be at risk from the influx of cosmic debris and radiation. The sudden influx of information from observatories worldwide might overwhelm existing analytical frameworks, leading to delays or missed opportunities in interpreting the data. Beyond the scientific and technological implications, Betelgeuse's explosion raises profound ethical and philosophical questions. How should nations prioritize resources for studying and responding to the event? Could disparities in access to data and technology widen global inequalities? Discoveries from the supernova could lead to advancements with both civilian and military applications. How should the global community regulate such technologies? The event could reignite debates about humanity's role as observers and participants in the cosmos. Will it inspire a renewed sense of unity and purpose, or deepen divisions over access to space and scientific knowledge? As the countdown to Betelgeuse's potential supernova continues, humanity stands at a crossroads. The event could redefine our understanding of the universe and our place within it, but only if we are prepared to seize the opportunity. This requires investing in advanced observatories and satellite systems to detect and analyze cosmic events in real time, strengthening partnerships between space agencies, academic institutions, and private companies to share data and resources, and educating and involving the public in the scientific process to foster a sense of shared purpose and curiosity. Ultimately, Betelgeuse's explosion could be a turning point in our exploration of the cosmos. Whether it serves as a gateway to new discoveries or a reminder of our limitations will depend on our collective ability to prepare, adapt, and learn from extraordinary event. As scientists continue to monitor Betelgeuse's instability, the potential for unprecedented discoveries grows. The event could mark a pivotal moment in the study of stellar evolution, supernova mechanisms, and the formation of black holes. For researchers, the opportunity to observe the birth of a black hole or neutron star in real time would be invaluable, offering critical insights into some of the most mysterious and extreme environments in the universe. The implications extend far beyond academia. If Betelgeuse's explosion occurs within the next few decades, it could directly affect satellite systems and space missions. With the global reliance on satellite infrastructure for communication, navigation, weather forecasting, and defense, the potential disruption caused by a cosmic explosion could have far-reaching consequences for daily life on Earth. Additionally, the risk of increased radiation exposure to astronauts aboard the International Space Station, ISS, or future missions to the Moon or Mars is a serious concern. The development of advanced radiation shielding and emergency protocols for space missions will become even more critical as we venture further into deep space. Space agencies such as NASA, ESA, and others are already working on contingency plans to mitigate the effects of a supernova explosion. These plans include bolstering satellite protection, improving radiation detection systems, and creating strategies for navigating the potential geomagnetic storms that could result from the explosion. The collaboration between governmental agencies and private companies, such as SpaceX, is essential to ensure that we are prepared for the worst-case scenario. Moreover, Betelgeuse's explosion could have significant cultural and societal impacts. The visual spectacle of a supernova could be visible from Earth, potentially rivaling the brightness of the full moon for weeks or even months. This extraordinary event could capture the imagination of people around the world, inspiring a renewed interest in space exploration and science. However, the global visibility of such an event could also spark public concerns about the risks associated with cosmic phenomena and the readiness of humanity to face them. On a philosophical level, the impending explosion of Betelgeuse raises profound questions about the nature of the universe and humanity's place within it. For centuries, humans have looked to the stars for answers to questions about life, existence, and our role in the cosmos. The potential explosion of such a massive star forces us to confront the vastness and unpredictability of the universe. It serves as a reminder of the fragility of life on Earth and the ever-present possibility of cosmic events that could reshape our world in an instant. As we wait for the inevitable, scientists continue to refine their models and predictions, striving to understand the complex dynamics of stars like Betelgeuse and their eventual fate. The next few decades could be critical in determining how we prepare for and respond to the event. With the right tools, international cooperation, and public engagement, humanity may not only survive the fallout from Betelgeuse's explosion, but also emerge with a deeper understanding of the cosmos and our place in it. In the end, the countdown to Betelgeuse's supernova is more than just a scientific curiosity. It is a test of our readiness to face the unknown. It challenges us to think about how we can harness the power of technology and knowledge to protect ourselves from cosmic threats, while also encouraging us to embrace the wonder and mystery of the universe. As we look to the stars, we must ask ourselves, are we prepared for what lies ahead, and how will we respond when the universe reveals its secrets?